Alright, let's look at homework 5, problem number 8. Alright, so we want to prove this equation here. Alright, so instead of looking at the cosine of theta, we're going to look at the real part of e to the I theta plus e to the I 3 theta plus e to the I 5 theta, and so on. And the last one is e to the I 2n minus 1 theta. Alright. So since this guy is actually a geometric series right here, where a is, so the first guy, so e to the I theta, and r value is going to be, so every time you go to the next term, you multiply by e to the I 2 theta, right? So the sum is going to be, so we can just use the formula here, so I'm going to actually go here. Alright, a is e to the I theta, and 1 minus r, and which is I 2 theta, raise it to the n, so 2n theta over 1 minus e to the I 2 theta. Alright, then we can do this manipulation. So let's focus on this guy right here. Alright, that guy can be rewritten as, let's see, 1 minus e to the I 2n theta. Right, so I'm going to pull out the negative e to the I n theta. Right, so if you pull out the negative e to the I n theta from 1, you get the negative e to the negative I n theta. Right, you can double check. If you multiply these together, negative negative makes it positive, and these are reciprocal of each other, so it's going to give you 1. Right, if you factor negative e to the I n theta from negative e to the I 2n theta, you're going to get e to the I n theta. Alright, then to create a sine expression, you can just divide this guy through by 2i, then multiply by 2i so that we don't change its quantity. Right, but you can see that this is going to be a sine of n theta. So this is equal to negative 2i e to the I n theta sine of n theta. Alright, so we got that. Then we're going to use that to find the expression for the denominator here too. Right, only difference is n equals 1, so you know that 1 minus e to the I 2 theta is going to be negative 2i. Then you have a e to the I theta and a sine of theta. Alright, so once you have that, then we have the expression for this guy. So I'm going to go down here. Alright, so you have e to the I theta. Alright, the numerator is this guy, so it's a negative 2i e to the I n theta sine of n theta. Alright, then bottom is negative 2i e to the I theta sine of theta. Alright, so let's simplify. So we can cancel e to the I theta here and e to the I theta there. and negative 2i there, and negative 2i there, right? So this is going to be, oh, I forgot to put the real part, sorry about that. All right, and this is going to be still the real part of that expression. All right, then you can see that this is going to be, right, so we're looking for the real part. So sine of n theta over sine of theta is just going to be a real. So I'm going to put that in front. All right, sine of theta, right? But e to the in theta, using Euler's formula, this is going to be a cosine of n theta plus I sine of n theta. But since we were looking at the real part, this is going to be cosine of n theta. All right, then what we can do is I'm going to multiply top by 2 and the bottom by 2. The reason why I'm doing that is that if you have 2 sine of n theta cosine of theta, that will be the 2 sine of 2n theta. So it's a sine of 2n theta, right? So that's these guys right here. So using a trig identity, and divided by 2 sine of theta, right, which is the expression we're looking for. All right, so this is part A. All right, in order to do part B, only difference is it's actually exactly the same geometric series, except that you would have to do part B would be, you would have to take the imaginary part of the expression. So when you go from when you take the real imaginary part of this, you're going to end up with sine of n theta there. All right, so that's how you do part B, but I'll let you complete part B. All right, that's it. I hope that this was clear.